Hi, listen viewers. In our chapter acids, bases and salts, we have seen already the chemical properties of acids and bases, reaction of acids and bases with metals, the liberate hydrogen gas, and also we have seen about some natural indicators, synthetic indicators, how do they change the color of the substance in acidic and basic medium, and also we have seen some olfactory indicators and examples also. And as reaction of acids with metal carbonates and metal hydrogen carbonates, they liberate carbon dioxide also we have seen, and also the reaction of metal oxides with acids, non-metal oxides with bases. Metal oxides with acids, they similar like neutralization reaction. So because of that, what we conclude here, metal oxides are acidic in nature. Non-metal oxides similar to they react with the base, and similar to neutralization reaction, they liberate salt and water. So as a result, what we conclude here, non-metallic oxides are basic in nature. Non-metal oxides are acidic in nature, non-metallic oxides are basic in nature. Okay, we have seen our topic up to there. So now today's our topic is, what do acids and bases have in common? Means what element is common in acids and bases. Okay, if you observe our previous activities, chemical properties of acids and bases. And reaction of acids and bases with metals, they liberate hydrogen gas. So from that, what we can consider, acids have hydrogen, H plus or hydrogen ions. Hydrogen element is common in acids. Okay, we can consider. So first we have to discuss about what do acids have in common. So if the hydrogen element contained in a substance, the substances, whether all compounds containing hydrogen or acids or not. Okay, for example, all the compounds, why I am saying means, for example here glucose. Glucose is C6H12O6. Here hydrogen element is present. Okay, this is the compound containing hydrogen, whether it is an acid or not. Means what is our question here? What do acids have in common? The same question, they will ask the question like this for 4 marks. Okay, describe an activity to show whether all compounds containing hydrogen or acids are not. Okay, so to verify that, we have to perform one activity. So here glucose, it contains hydrogen element, but it is an acid or not. The compounds, all the compounds containing, the compounds which are containing hydrogen element, they are considered as acids, or based on which property we can consider as whether the compound contains a hydrogen element, we can consider as acid. So we have to perform that activity. So to perform the activity, the question also they will ask like this: describe an activity to show acids conducts electricity. Same, what common element is present in acids, or describe an activity to show that whether all compounds containing hydrogen or acids are not, or describe an activity to show the acids conducts electricity. So to verify this, we have to perform one activity. So for that, we have to prepare solutions. We have to prepare the solutions of glucose, hydrochloric acid, sulfuric acid, sulfuric acid, glucose, and alcohol also. Okay, we have to prepare these solutions. Okay, and we have to take 100 ml of beaker. 100 ml of a beaker, and we have to take two different color electric wires. The two different colored electric wires we have to connect with two graphite electrodes. Okay, two different colored electric wires. So for example, this is a red color electric wire, like a copper wire, and again this is like green. Okay, so two different colored electric wires, we have to connect the one end of the electric wires with electrodes, two graphite electrodes. Okay, these two are what? Graphite electrodes. sometimes they will also ask only draw the diagram to show the acids conducts electricity. So that's why here we need to draw the diagram also perfectly. So now two different colored electric wires we have to connect at the end of the graphite electrodes. So now other end of the red color electric wire, the other end of the red color electric wire we have to connect with AC plug. Okay, 230 volts AC plug we have to connect the red color electric wire. Red color electric wire, one end is connected with the electrode, graphite electrode, the other end connect with the AC plug, and green color electric wire. So the green color electric wire, one end connect with the graphite electrode, the other end we have to connect with the bulb. The other end we have to connect with a bulb. Okay, like this we have to complete the circuit. We have to complete the circuit, and now we have to pour in a 100 ml beaker. We have to place these two electrodes, and at the two ends of the graphite electrodes we have to connect two different colored copper wires, and one end of the copper wire we have to connect 230 volts of AC plug, the other end of the copper wire again we have to connect with the bulb, and these two electrodes we have to immerse in a dilute. Pour now dilute hydrochloric acid solution. Dilute hydrochloric acid solution, pour into the beaker. Okay, this is beaker. Like this way we have to complete the apparatus. We have to take one beaker, and we have to take dilute hydrochloric acid solution to test, to verify this activity. First we have to prepare the solutions of glucose, alcohol, hydrochloric acid, sulfuric acid. 4 solutions we have to prepare. Okay, so now we have to take two different colored electric wires, connect the two electric wires with two graphite rods, and also connect one electric wire with 230 volts of AC plug, another electric wire connect with the bulb, and complete the circuit. Now pour the dilute hydrochloric acid solution in a beaker and switch on the plug. Okay, switch on the plug and observe what happens in this circuit. Okay, and observe what happens in the circuit, and in the same way we have to do the activity with the hydrochloric acid, and also observe what happens, and afterwards you have to do the same activity with the sulfuric acid, and also with glucose, and also with the alcohol. Okay, pour one solution, and you have to observe what happens in the circuit. Okay, first we pour the dilute hydrochloric acid in a beaker, and we have to observe, does the bulb glow in every case, in all the cases does the bulb glows or not. What do we observe? We have to observe, does the bulb glows in all solutions, in all these solutions does the bulb glows or not. Okay, what do we observe while doing this activity? Only the bulb glows only in acid solutions. In these 4 solutions, which are acid solutions here? Dilute hydrochloric acid and dilute sulfuric acid. These two are acid solutions. Okay, only the bulb glows in acid solutions we observed. Okay, the bulb does not glow in glucose and alcohol. The bulb does not glow. Bulb does not glow in glucose and alcohol. So what happens? Why the bulb glows in acid solutions only? Why does the bulb not glow in glucose and alcohol solution? What is the reason to glow the bulb in only particular acidic solutions only? Okay, means here these acid solutions contain ions. For example, here hydrochloric acid. Hydrochloric acid, when electric current passes, when we switch on the plug, when electric current passes through these electrodes, through the solution, these hydrochloric acid solution dissociates into hydrogen ions and chloride ions. Okay, hydrogen ions and chloride ions. So when the electric current passes through the electrodes into the solution, the hydrochloric acid solution, it contains H plus ions. The movement of these H plus ions makes the electric current to flow in the solution. Then we observe the glowing of bulb in acidic like hydrochloric acid solution. In the same way, sulfuric acid solution also, H2SO4. It also dissociates into H plus ions and HSO4 minus ions, bisulfate ions. Okay, these movement of ions responsible for the flow of electric current within the solution. Okay, so here but in glucose and alcohol, why we doesn't observe the bulb does not glow, means there is no movement of ions, there is no H plus ions in glucose and alcohol, the absence of hydrogen ions in glucose and alcohol. So because of that, there is no movement of ions in the solution, that's why we do not observe the glowing of bulb in which solutions, glucose and alcohol solution. The movement of ions in these two solutions, these two are acidic solutions, these two, hydrochloric acid and sulfuric acid, these both are acidic solutions. In acid solutions, they contain what type of ions here? H plus ions. These movement of H plus ions only responsible for the movement of for the flow of electric current within the solution. Okay, for the movement of electric current within the solution from one electrode to another electrode to complete the circuit, and the current flows towards the bulb and the bulb glows. Okay, we observe the glowing of bulb in which solutions only? Acidic solutions. They are hydrochloric acid and sulfuric acid. So here from this, what we can understand here, acids, they have which type of element is common? Glucose and alcohol. Alcohol also the formula C2H5OH. Look at here. Here also hydrogen element is present in alcohol. Glucose C6H12O6. Glucose and alcohol also have hydrogen element in them, even though they, we do not observe the glowing of bulb in these two solutions, glucose and alcohol, but only we observed the glowing of bulb in these two, hydrochloric acid and sulfuric acid, acidic solutions only, because if even though they have hydrogen ions, there is no movement of hydrogen ions when electric current passes through them. Okay, so here in acidic solutions, the movement of hydrogen ions only responsible for the flow of electric current through the solution, and reason for the glow of bulb in this circuit. Okay, so that is why what we can confirm here, acids means all the compounds, whether all the compounds containing hydrogen or acids or not. No, all the compounds, if they contain hydrogen, they are not acids. Okay, if they contained hydrogen and movement of hydrogen ions takes place within the solution, then they behaves as an acids. Okay, if the compound containing hydrogen means we do not confirm that is a acid, means what acids have hydrogen element in common, but all the compounds containing hydrogen are not acids. Okay, acids, all acids containing hydrogen common, but all the compounds containing hydrogen are not acids. Okay, with this activity we can prove that, because glucose, alcohol, even though they contain hydrogen element in them, they don't show the acidic property, because there is no movement of hydrogen ions in the solution. Only the movement of hydrogen ions only responsible their acidic property of acids. Okay, here the movement of hydrogen ions, or the number of hydrogen ions, means strength of hydrogen ions only attribute for the acidic property of the acids, means hydrogen H plus ions only responsible for the acidic property which attribute the acidic property of acids, which are responsible, H plus ions only responsible for the compound behaves as an acid. Okay, so from this activity we can confirm here, if the compound contain hydrogen and if they dissociate or if they contained H plus ions, it behaves as an acid. It has acidic property. The substance behaves as a acid, and it also has a acidic property. So from this activity they will ask like different in different way question. They will draw the diagram to show the acids conduct electricity, they will ask, or write the materials, what are the materials required to show the acids conduct electricity also they will ask for 2 marks, or what element is common in acids, how do you prove it? Okay, with an activity, describe an activity, what element is common in acid. Okay, or describe an activity to show the acids conducts electricity. So we have to prepare for compounds contained hydrogen for different solutions, and we have to perform this activity, and we can confirm, in which case the bulb glows, in which case does the bulb glows or not. Okay, which is responsible. In acidic solutions only we observe the glowing of bulb. Which is responsible? The H plus ions only responsible for the acidic property of the substance. So here, like the way we can verify the acids conducts. So from this, what we can also understand here, glucose and alcohol solutions do not conduct electricity. Only the acid solutions only conducts electricity. So the same activity, we can also write the answer for the question. Describe an activity to show acids conducts electricity also. Okay, so we have to draw the diagram and give the answer like this. And what chemical reaction is chemical reaction means it conducts electricity. So here our topic is what do acids and bases also have in common. In the same way, we have to consider different bases. Instead of dilute hydrochloric acid, we have to consider sodium hydroxide, calcium hydroxide. So like this, different bases also we have to take in a beaker, 100 ml of beaker, take in 100 ml of beaker, and also we have to observe in every time does the bulb glows or not. So here in acid solutions, H plus ions are responsible for the acidic property. In the same way, if we consider the basic solution in a beaker, which ions are responsible for the glowing of bulb? Okay, different solutions we have to consider, and in each case we have to observe. Does the bulb glows or not. Okay, in basic solutions also. Here sodium hydroxide, when electric current passes through the solution of sodium hydroxide, it dissociates into its ions like metal ion and hydroxide ion. So whatever the base if we can consider here, calcium hydroxide, if we can consider also calcium ions and also hydroxide ions. So like this, if we can consider any kind of base, it has common what kind of ions in them? Hydroxide ions. So when we placed the basic solutions in a beaker, which ions are responsible for the basic property of the substance means hydroxide ions. The movement of hydroxide ions are responsible for the flow of electric current within the solution. So from that, what we can confirm here in bases, what kind of ions are common here? Hydroxide ions are common in all kinds of bases. Sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide. So if we can consider any base, it has what kind of ions in common? Hydroxide ions are common in all kinds of bases. Okay, by taking the basic solutions also we have to observe every time, and we have to confirm that the hydroxide ions only responsible for the basic property of the substance solution, and movement of hydroxide ions takes place when electric current passes through these electrodes into the solution. Movement of hydroxide ions only responsible for the flow of electric current to glow the bulb. Okay, in the circuit we have to observe. So from this way we have to confirm what do bases have in common? Hydroxide ions. We have to confirm the bases have hydroxide ions in them, and also acids have hydrogen ions, H plus ions in common. Okay, so with this activity we can prove what do acids and bases have in common. What do acids have in common? What type of ions or what is the element is common in acids? Hydrogen element, but ion is H plus ion is common in acids. And bases, what ions are present means what do bases have in common? What do bases have in common means hydroxide ions. Bases have hydroxide ions common. If the substance contain hydroxide ions, that acts as a base, that show the basic property. Okay, if the substance contains hydroxide ion, that shows their basic property. The movement of hydroxide ions within the solution, we have to observe the flow of electric current within the solution to glow the bulb. Okay, so here acids have hydrogen ion common, we are considering. Okay, do the acids produce? So here our next activity, this also sometimes they ask for 4 marks. Do acids produce ions only in aqua solution? Do acids produce ions only in aqua solutions? Okay, let us look at an activity. Okay, let us perform an activity to prove that do acids produce ions only in aqua solutions. Just now we have seen in the activity, in solution, dilute hydrochloric acid solution. Dilute means what? It is mixed with water. Means hydrochloric acid solution, it produces hydrogen ions. Movement of hydrogen ions only responsible for the flow of electric current. Just now we have seen. In the same way, do acids produce ions only in aqua solutions? Aqua solutions means, aqueous means what? If the solution, if the substance dissolved in water, that solution, if the substance or a salt or a compound, if it is dissolved in water, that solution we can say to as a aqua solution. In aqua solution only the acids produce ions, or in dry condition also the acids produce ions or not, we have to verify. This question also many times they ask for 4 marks. Okay, so to give the answer for this question, we have to perform a small activity. Okay, we have to take a dry and clean test tube. To do this activity, what we have to consider here? Dry and clean test tube. And also we have to take here 1 gram of sodium chloride. Okay, 1 gram of sodium chloride crystal we have to consider in a test tube, and test tube should be dry and clean test tube. Okay, 1 gram of sodium chloride we have to take in a dry and clean test tube, and we have to add concentrated, not diluted, not mixed with water. Okay, concentrated sulfuric acid. We have to add concentrated sulfuric acid to the 1 gram of sodium chloride in test tube. Okay, which kind of test tube we consider here to do this activity? Dry and clean test tube. So when sodium chloride dissolve in sulfuric acid, okay, they release which gas? Look at here, hydrochloric acid in the form of gas, and also sodium sulfate like a salt, aqueous. Okay, this is solid. Sulfuric acid, not aqueous here, concentrated solution, means like liquid. Sodium chloride, 1 gram of sodium chloride we considered in dry and clean test tube, and we added concentrated sulfuric acid. So which gas is releasing here? Hydrochloric acid gas. So here from the at the mouth of the test tube, we have to test here pouring of sulfuric acid we have to pour slowly. Concentrated sulfuric acid we have to add to the test tube of 1 gram of sodium chloride. So now here the gas evolves. When the chemical reaction takes place between sodium chloride and sulfuric acid, the gas evolves. That evolved gas we have to test with the same test tube again. Concentrated sulfuric acid, same test tube we have to close with one hole rubber cork, and through this one hole rubber cork deliver tube will pass the deliver tube through the one hole rubber cork. Okay, so now here we have to place, here we have to take two blue litmus papers that evolved gas we have to test with two blue litmus papers, that is one is wet and the second one is dry. Two blue litmus papers, the evolved gas from the mouth of the test tube, from the mouth of the test tube with 2 blue litmus papers, evolved gas from the mouth of the test tube, test with 2 blue litmus papers. One is wet litmus paper and dry litmus paper. So now near the mouth of the delivery tube, I placed first wet dry litmus paper. I placed dry blue litmus paper. Why do I consider here only blue litmus paper? The blue acids turns blue litmus into red. Okay, in the present, to know the nature of the substance, we use litmus paper is blue. Here I am considering 2 blue litmus papers. One is wet and one is dry. Here first I placed near the mouth of the delivery tube dry blue litmus paper. And I observed, is there any change in the color of the blue litmus paper? If hydrochloric acid gas, if the gas of hydrogen chloride evolves through the test tube, the blue litmus, if it is dry or wet, the blue litmus paper turns into red. Okay, but here dry litmus paper we have to test whether the color of the dry litmus paper changed or not, we have to observe. And again with the wet blue litmus paper also we have to place. Wet blue litmus paper also we have to place near the mouth of the delivery tube, and we have to observe in which litmus paper, blue color litmus paper, in which blue color litmus paper turns into red color, whether dry blue litmus paper turns into red or whether wet blue litmus paper turns into red, or we have to observe. When I test with the dry blue litmus paper, I did not observe the change in color of blue litmus paper. When I placed the wet blue litmus paper near the mouth of the delivery tube, I observed there is a change in the color of the wet blue litmus paper. Wet blue litmus paper only changes into red in color. Means what? Hydrogen chloride gas in the presence of in the presence of water only. Wet blue litmus means it contains which molecules here? Water molecules. Wet blue litmus means litmus paper contain water molecules. In the presence of water molecules only, hydrogen chloride, in the presence of water molecules only, it behaves an acid. So here hydrogen chloride, it decomposes into its ions in the presence of moisture. Wet blue litmus means it contains water molecules. In the presence of moisture only, the evolved hydrogen chloride gas decomposed into H plus ions and chloride ions. When I place a dry litmus paper, it do not decompose into hydrogen ions and chloride ions. When it decomposes into hydrogen ions, then only the hydrogen chloride acid behaves as an acid. Then it turns the blue litmus into red. But when we place it the dry litmus paper, so the hydrogen chloride do not decompose into hydrogen ions and chloride ions. That's why we do not observe the change in the dry litmus paper. But when I placed the wet blue litmus paper near the mouth of the delivery tube, what I observed here? Change in the color of the wet blue litmus paper. Why? Because in the presence of moisture or in the presence of water molecules only, hydrogen chloride acid decomposes or dissociates into H plus ions and chloride ions. When acid dissociates into H plus ions, then only it behaves as an acid. So these H plus ions combines with water molecules and form as hydronium ions. Okay, means acids. When acids do not contain, or acids do not contain only H plus ions, do not contains only bare H plus ions. Bare means like a single H plus ions. Okay, they combine with water molecules, and as they combine with water molecules, and what kind of ions present in acids? H3O plus ions are also called as hydronium ions. Hydronium ions. Now what we can say to as acids have what kind of ions in them? Hydronium ions. When the substance or when the gas behaves as an acid in the presence of moisture, in the presence of water molecule, it dissociate into hydrogen ions and combine with water molecule and form as a hydronium ion. Means all acids, they have what kind of ions? Hydronium ions, means H3O plus ions. In acids, they do not contain bare hydro H plus ions. Bare means single H plus ions they do not contain. It combined with water molecules, then only that substance behaves as an acid. When the acid contains H3O plus ions, then only it shows its acidic property. So that's why what we can say, acids have what kind of ions in common? Hydronium ions. So these H plus ions in acids will be attached. H plus ions in acids will be attached by 4 to 6 water molecules. 4 to 6 like this will be attached. On single H plus ion in acid will be attached with 4 to 6. 4 to 6 water molecules will be attached. Okay, one single H plus ion in acid will be attached with how many water molecules? 4 to 6 water molecules combined with one H plus ion. And in acids, hydronium ions will becomes responsible for the acidic property of an acidic substance. Okay, 4 to 6 water molecules will be attached. So like this, acids produce ions only in aqueous solutions, not in dry solutions. In dry solutions, acids do not produce ions. In what kind of solutions? Aqueous solutions. Aqueous solutions means it contains what molecules? Water molecules. In the presence of water molecule only, the acid dissociate into its ions, hydrogen ions. These hydrogen ion combine with water molecule and form as hydronium ion. So this hydronium ions only responsible for the acidic property of an acids. So that's why in this activity we have to observe acids produce only ions in the presence of aqueous solutions. So while doing this activity, we have to take some precautions. So what kind of precautions we have to take means, while doing this activity, if the climate is very humid means already the water vapor is more amount of water vapor will be present. Okay, when the evolved hydrogen chloride gas, this precaution is for teachers. The evolved hydrogen chloride gas, if the atmosphere is more humid, the evolved gas, hydrogen chloride gas will combine water molecules with the atmosphere, and dry litmus paper also turns into blue. So because of that, if the atmosphere is more humid, we have to send the evolved gas into the another test tube. We have to send the evolved gas into the another test tube. The test tube should contain calcium chloride to dry the gas. Calcium chloride into the test tube of calcium chloride. Why do we send the evolved hydrogen chloride? Means hydrogen chloride gas to become into dry, to test the to dry the gas, evolved gas become into dry. We have to, if the atmosphere is more humid, this precaution we have to take to perform this activity perfectly. Means only acids produce ions in aqueous solutions only, not in dry solutions. Only in the presence of aqueous solutions only, acids produce hydrogen ions and attached with the H2O molecules and formed as hydronium ions. Okay, like this way, acids they contain H plus ions and combine with water molecules and form as hydronium ions. All acids have which kind of ions in common? H3O plus ions or hydronium ions. These when H plus ions in acids combine with the water molecule, then only the substance, then only the solution shows its acidic property. Then only they shows their acidic property. In aqueous solutions only we have to perform like this activity. And also while doing this activity, we have to take some precautions. While doing this activity in a laboratory, we are using here concentrated sulfuric acid. So when we are doing the activity with the concentrated solutions, we should use a test tube holder to hold the test tube. What we should use? A test tube holder. This precaution we must and should take. Okay, we should not handle the test tubes with bare hands. Bare hands means without wearing any gloves or without a holder. We should not perform the activity with concentrated solutions with our bare hands. We need to take a precaution while doing this activity to take the test tube, to hold the test tube with the test tube holder. Test tube holder means the handle of the test tube holder will be wood. So that's why while doing the activity with concentrated acids, we need to take precaution. Okay, sometimes they will also ask for 1 mark, what precautions we need to take while doing this particular activity. Means what kind of precautions. To do every activity we need to take some precautions, so in laboratory. So that's why they may ask. So precautions also we come to know. So here In this activity, acids produce ions only in aqueous solutions. In the presence of water molecules only, acids behaves acidic property, and also acids contain hydronium ions. In the same way, what do bases, what kind of ions the bases contain? What kind of ions bases contain in aqueous solutions? When the bases dissolve in aqueous solution, what kind of ions they have? Here just now we have seen acids, when they dissolve in water only they produce ions and they contain hydronium ions. Each H plus ion is attached by 4 to 6 water molecules. In the same way, bases, for example here sodium hydroxide in the presence of water, magnesium hydroxide in the presence of water, means when they dissolve in water like aqueous solution, calcium hydroxide in the presence of water. Okay, so here sodium ions and hydroxide ions, magnesium ions and hydroxide ions, calcium ions and hydroxide ions, like potassium hydroxide in the presence of water molecule, potassium ions and hydroxide ions. If we observe all the bases in aqueous solution, okay, all the bases in aqueous solution, all bases in aqueous solutions, contain what kind of ions in common? Hydroxide ions. Hydroxide ions, they contain hydroxide ions, OH minus ions, what we can read as hydroxide ions. Hydroxide ions they have common. Okay, hydroxide ions, all bases in aqueous solution they contain, means they dissociate into their ions like metal ions and hydroxide ions, whatever it may be the acid. But here all the acids which are dissolved in water, the bases which are dissolve in water, the bases which are dissolves in water are called, which are dissolves in water are called alkalis, but all bases they do not dissolve in water. For example, beryllium hydroxide, it is a slightly dissolves in water, beryllium hydroxide slightly dissolves in water. The bases which are dissolves in water, here all these are alkalis because they are dissolving in water and they are producing hydroxide ions. So here but all the bases do not dissolve in water to produce hydroxide ions. For example here beryllium hydroxide, it is slightly dissolves in water. So the bases which are dissolves in water are called alkalis. So from this activity what we can confirm here, acids produce ions only in aqueous solution, and acids have what kind of ions common? H3O plus ions, and bases have which kind of ions? Hydroxide ions. Okay, hydroxide ions have in common, acids hydronium ions and bases hydroxide ions they have in common, and acids produce only ions in aqueous solution, not in dry solutions. Dry solutions it behaves as a gas, but it do not behave as an acid. Okay, in the presence of aqueous only it behaves as an acid. So like this way we have to verify and we have to confirm what element is common in acid, or what kind of ions are common in acids and bases. In acids, from these activities what we can confirm here, in acids what kind of ions? H plus ions or hydronium ions are common in acids. Or the same question, describe an activity to show the acids conducts electricity. Same, the bases also conducts electricity with the help of movement of hydroxide ions. The bases also have what kind of ions in common? Hydroxide ions, OH minus ions. So for the responsible of the movement of these ions, only responsible for the flow of electric current. So because of that reason acids conducts electricity. In the same way bases also conducts electricity. To conduct electricity we need movement of ions from one electrode to another electrode to glow the bulb within the circuit. So that movement of ions is present in acids and bases. So that's why acids also conducts electricity and bases also conduct conducts electricity. So from this activity we can also confirm the common ion present in acids, hydrogen ion or hydronium ion, and all the bases have common ions or hydroxide ions. So like this way, with these two activities we can confirm the bases which dissolves in water are called alkalis, but all the bases do not dissolve in water. For example, beryllium hydroxide slightly dissolves in water. So like this way. And also, how do we, here in this activity we consider concentrated sulfuric acid, but in all the cases we do not use concentrated sulfuric acid. In most of the experiments while doing in the laboratory, we need to use diluted acids. So how do we make an acid or a base into dilute, and how do we follow the process of dilution? Okay, that process, which kind of process that is an exothermic process or endothermic process, we have to look at in our next class. Okay, thank you.